All right, guys. So in this section here, I want to go over maybe what is very important, and we're kind of getting into the nitty gritty now, and that's we want to know coordinate points of our unit circle. We want to know what are the coordinate points of our unit circle. How do we get these particular coordinate points? Now, for example, at this particular coordinate point, right, since the radius is always 1 of our unit circle, the radius is always 1, this length is 1, that's why it's 1 comma 0. The length up here is 0 comma 1, negative 1 comma 0. The length is 1, but because it's in the negative x-axis, it's negative 1 comma 0, 0 comma negative 1. We talked about two very important triangles. Those two very important triangles are 45 degrees and 30 degrees. So let's take a look at our 45 degree. Now we want to know what is the exact coordinate point here. Basically, what is the exact x value and what is the exact y value here, and we're slowly going to decipher why this whole unit circle plays a big part in calculus. Now what can we do? We can draw a triangle, right? And we can begin to use some right triangle geometry to get these coordinate points. We know this is 45 degrees. Now, do you remember what I said to you guys about what is special about 45 degrees right triangle? That's that these two lengths are the exact same thing. So we're actually going to use that to try to figure this out. Now, here's what's kind of cool. What is the radius? Yeah, you're right. The radius is 1. Well, guess what? The radius from here to here, or the length, is 1. That's our radius, right? From the center to any point, the length is 1. So this length is 1. So if we use Pythagorean theorem, we get L squared plus L squared is equal to 1 squared. This is actually going to become 2L squared because you have two copies of these, is equal to 1 squared, which is 1. Let's divide 2 to both sides. We get L squared is equal to 1/2. Let's go ahead and take the square root of both sides. And when we take the square root, we can just take the square root of top and bottom. So we get L is equal to the square root of 1 is just 1 divided by the square root of 2. We're done. Now we know what this length is here, but in math, we don't like having square roots on the bottom. So we want to rationalize them. All we do is multiply top and bottom by the square root of 2. 1 times the square root of 2 is the square root of 2. Right? 1 times 2 is 2. 1 times 3 is 3. So 1 times the square root of 2 is the square root of 2. What's 2 times 2? Because they're both underneath the square root, we can combine them, the square root of 4. So we get the square root of 2 divided by the square root of 4 is 2. So now we know this length right here, this length is actually the square root of 2 over 2. Now if you use that on your calculator, you'll get what that actual coordinate value is. I think it's like 0.8 something or something like that, and it obviously has to be smaller than 1, right? Because we are, or I forget what it is, I think it's 0.7 something. Let's actually do it. 0.707. So that makes sense, right? This length is 1. We're pretty close. So this length right here is 0.707. Again, we don't like decimals, so we'll keep it like that. So we can now conclude that the x coordinate is square root of 2 over 2, or 0.707. And the y, the length from here to here, is also square root of 2 over 2. Which is, if we look over here, at our unit circle, that's where this comes from. Square root of 2 over 2, square root of 2 over 2 at pi over 4. Now, if you notice, anything that is multiples of pi over 4, it's like these are mirror reflections. This is negative square root of 2 over 2, square root of 2 over 2. Now, why would that make sense? Well, basically, these 2 points are identical to each other, right? They're the same lengths. This is a mirror reflection. But the only thing different here, in case you're wondering, it's the same triangle as this one. This is 45 degrees, is that we're in the negative x-axis. So this is why this is square root of 2 over 2, but it's negative, but the y value is positive here, square root of 2 over 2. So that's essentially how we can fill in a lot of these portions. This right here is the same 45 degree right triangle as this one, but now they're both going to be negative, and that's why if you look over here, they're both negative. Over here, you're in the positive x-axis, so now this is why the y value is negative and the x value is positive. So that's how we can get the coordinate point for a 45 degree triangle. In the next video, we'll talk about how to get the coordinate point for a 30